Hi Algebra 2, we are getting into a chapter that I think is a lot of fun, and this is probabilities. You guys are oftentimes asking me, well, how do you know? How do you know? What do you do? How do you do this? How do you tell if this is gonna happen or not? Well, that boils down to probabilities. So you guys can expect at some point in this chapter, I'm gonna have you do an extra credit assignment that's going to be you setting up your own probabilities for something. I'm gonna assume you went ahead and read 494 to 495, so I'm going to jump straight into relative frequency. So the relative frequency formula simply states that it's the number of successful outcomes over number of total outcomes. So it's the number of times that you succeeded over the number of times you tried. So this is just relative, and this is just going to be success over tries. Now I know I'm simplifying that a lot, but that may be the easiest way to know this. So this is the number of times that you would select, if I put everybody's names in a hat and you would select the person you wanted to sit next to in the class. That is your success versus how many different times how many other names there would be. So for Algebra 2, there are 6 of you. If we say, what are the chances that Sergio is going to pick John's name out of a hat, it would be 1 out of the 6, because remember I did put Sergio's name also in there. So he has 6 different tries that he would have to make to for sure get John, but there's only going to be the 1 success. So that is what relative frequency is. Now, they use this in example A and example B with marbles. I'm going to kind of skip over those because I think that kind of makes sense. They tell you flat out how many marbles there are. For example A, you may have to count them, but they still tell you how many there are. There are 8 total outcomes. There are only 3 blue marbles, 3 over 8. So I'm going to assume that those are kind of understandable. So I'm going to get into the rules of probability. This is an important one here. So the rules of probability. I'm going to try and spell this out as best as I can for you, okay? So the rules of probability. You ready for this? I don't think you're ready for this. Basically, for the data to be valid, okay? To be valid data, it must equal 1. Yes, plain and simple. To be valid, the data has to add up to 1. When you're dealing with the decimal version of percents, 1 is 100%. You can't have 110% of data. The data is only going to ever be complete at best. If you don't have it being complete, if it only adds up to like 0.8, you're dealing with incomplete data there, so it's not valid at that point. So you're going to get a couple of problems like these that are saying, are they valid? It just wants you to say yes or no, do they add up to equal 1? Okay, if they don't add to equal 1, they're not valid. If they do, we're good. Okay, now, basically, if you end up, one of the things with this is if you end up with a negative number in here, you still add it in. So if it gives you like negative 0.3, and then it gives you negative 0. Or positive 0.8, and then 0.5, yes, it's less than 1, okay? The first probability is less than 1. You also have to check that each individual probabilities are going to add together to equal 1. Well, 8 minus 0.3. Okay, this is going to be 0.8 minus 0.3, which is going to give me 0.5, and then I'm going to add my 0.5. Yes, it does equal 1. However, that doesn't work. Guess what? You can't have a possibility of something happening being less than it happening. You can't have negative probabilities. So it has to equal 1, and there can be no negative data. Okay? You can't have negatives. This is a big no. So one of the quick ways of doing this is look over it. If there are negatives, it's automatically not valid. Okay? So it doesn't matter that equals 1. If it has a negative in it, it's automatically not valid. Okay? Now, another thing I want to do is I want to talk to you guys about complements. And I know there's a lot of these here. So I'm going to fold my paper over real quick, and we're going to talk about complements in data. Now, do not get confused with this statement. Don't get confused with that word and think, oh, I have to make it add up to equal 90 degrees. This is a complement when it comes to data. So if it tells you that you have a data that's given to you, so the probability of A happening is 0.2. To find its complement, so this is written as the probability of a complement. Notice that's an exponent there. That's just going to be 1 minus 0.2, okay? Which gives me 0.8. And do not get confused by this. It just simply means you take it away from the whole. So if I know, for example, say it's a fraction. So say the probability of B is, let's do 8 over 19. Okay? To find its complement, I would have to write 1 as a fraction that can subtract that. So I would do 19 over 19 minus 8 over 19, which would give me 11 over 19 as my complement. Again, you're basically just, for complements, subtracting it from 1. Okay? So, some probability rules that we're going to go over. Let me put this here. So some basic probability rules are this. It has to be between 0 and 1, which means it cannot have a 0, so you can't have a probability of 0, and you can't have a negative probability because it has to be greater than 0 but less than 1. The sum of all the probabilities have to add up to 1, and the complement of some event is found by subtracting it from 1. So it and its complement combine together to equal a positive 1. Tomorrow we're going to talk about mutually exclusive events, and we're going to have some fun with that. So be prepared. I've turned into Scar from The Lion King. I don't know how that happened, but it did.